Here we have x points east, y points north. The xy plane is the surface of the water. B is a boat, so B has a coordinates 3, 4, 3, 4. So this is the boat. B is here. Has a coordinates 3, 4. The submarine is 9 units below the point S. So this is S. The point S has a coordinate 5, 1. But the submarine is 9 units below. So first one, S has a coordinate 5, 1. And the submarine 9 units below S. So let's put the submarine. So we are talking about in the three-dimensional space. The submarine has the coordinate 5, 1, minus 9, because it is 9 units below S, right? So the z coordinates, the z component is minus 9. The boat is on the surface of the water. Therefore, the z coordinates is 0. So B is the boat, which is B. Submarine, let me call it S. B is 3, 4, 0. And we have the helicopter is 12 units above 8. 8 is a point, has a coordinate 1, 2. 1, 2. So here's our point 8. 1, 2. Eight. Helicopter is 12 units above 8. Unit above 8. So the z coordinates is 12. Let me put helicopter. What is S? 1, 2. So we have 1, 2, 12. Okay. So now what do we need to compute? The displacement vector and the distance from the submarine to the boat. Okay. Displacement vector and the distance, which is the length of the vector from the submarine to the boat. From the submarine, we call it S, to the boat, which is B. Okay, so we need to compute vector SB. Vector SB is, in general formula, XB minus XS, YB minus YS, ZB minus ZS, which is, what is B? 3, 4, 0. 3 minus S, 5. 4 minus 1. And 0 minus 9, which is minus 2, 3, 9. Okay, so that is vector SB, and we need to find the distance. Distance is the length of vector SB, which is the length of this vector minus 2, 3, 9, which is square root of minus 2 squared, 4, 9, 81, which is here's in 1994. Okay, so that's the first question about the distance from the submarine to the boat. The second question is find the displacement vectors and distance from helicopter to the boat. Similar displacement vectors from helicopter to the boat. You do the same, you compute vector HB, okay, that is in general formula, which is xb minus x8, yb minus y8, and zb minus z8. So you just plug in all the coordinates here and you compute this vector, so that's a displacement vector. And now you compute the distance equals something, okay, and the distance, which is the magnitude or the length of the vector HB. Yeah, you apply the formula, which is square root of x HB square y HB square and z HB square, and you plug in the data you get from here, you get the length. And the last one is find the displacement vector from the submarine to the helicopter. You do the same thing from the submarine to the helicopter. So similar, compute vector S8 and compute the length of S8. That's how we do it.